So in this video, we're going to talk about naming and writing formulas for binary ionic compounds. So a binary compound is composed of two elements. And in this case, since it's a binary ionic compound, we are going to have a metal cation and an anion, which we know is a non-metal. Okay, so the first thing we need to do, we need to write the symbol of the cation and then the anion. We need to place the charge on top of each symbol. What I mean by that is this. Say I had sodium. I'm just going to write my symbol, Na, and I know sodium's in group 1, so it's going to have a positive 1 charge, so I'm going to put the +1 on top of it. Say we had, our formula was NaCl, so then our other anion is Cl, and we're going to have -1 since it's a halogen. Now where it says crisscross the charges, so this 1 is going to come here to the Na, and this 1 is going to come here to the Cl. So if I did that, I would have, it says place the crisscross number as a subscript to the right of the element that received the charge. So it would be NaCl, okay, 1 is understood. And it says drop any negative signs. We're not going to worry about any negative signs with our formulas. And it says reduce to lowest terms if possible. And we're at the number 1 right now for each subscript, so there's nothing else to reduce. So it's NaCl. Okay, so a few examples. So we have lithium nitride. So lithium is Li, nitrogen, nitride is N, so lithium is +1, nitride is -3. So what do we do now? We crisscross our charges. So the 3 comes down here to the Li, and the 1 comes here to the N. So we're going to have Li, 3, N. Now the next one, sodium oxide. So I'll combine steps here. So I have Na for sodium, and sodium's a +1 cation. Oxide, O, -2. Crisscross our charges. We're going to have Na2O. And then the last one here, we'll have aluminum, Al, and that's +3, and nitride, N, -3. So if I crisscross those charges, it'll be Al3, N3. But that last step wants me to reduce to lowest term. So I could divide each of these subscripts by 3 to get to ALN. And that will be my final answer. Now I'll erase these. We'll move on. So some examples here. So Li, now we're going to name these formulas, not just write them. So I have Li. So it's going to be lithium. You're just going to write the name of the metal cation. And then when we look at the anion, remember we have to change the ending to IDE. So it's not going to be lithium nitrogen. It's going to be lithium nitride. So Li3N is lithium nitride. Next one, we have NaO. So it's supposed to be Na2O. So it will be sodium oxide. And then the last one, NaI, it will be sodium iodide. Erase our slide. Now, ionic compounds with transition metals. So all the previous rules apply. Just make sure we include the charge of the transition metal in Roman numerals with parentheses. So for example, say we had, and I'll get my pointer here, my pen. So say we had Cu3N2. So to figure this out, I always look at my anion first. And I know that nitrogen has nitride has a -3 charge. So when I crisscross that 3 from the nitride comes to the Cu. So how do I figure out what the copper was? I need to look at the actual charge on, or subscript, next to the nitrogen, which is a 2, because this 2 comes from my copper. So it's a +2. So if I named this, it would be copper 2 nitride. Okay, so a few examples here. It says write the formulas for the binary ionic compounds formed between the following elements. So we have zinc and iodine. So I know zinc, Zn, and zinc is always +2. Iodine is -1. So if I crisscross my charges here, it will be ZnI2. Now, I look down at this one. Same thing for zinc. Zn +2. And then S -2. So if I crisscross these, it's Zn2 S2 ZnS. Because I want to drop that to lowest terms. So, write the formula and give the name for the compound formed by the ions chromium-3, Cr+3, and fluoride, which we know fluoride is F-1. So if I crisscross these charges here, it will become Cr3F. So now, ionic compounds with polyatomic ions, ATE or IT ending on the name of a compound indicated that the compound contains a polyatomic anion that includes oxygen. All of the same rules apply, but remember to place parentheses around a polyatomic ion that has a subscript that is greater than 1. So example, magnesium nitrate. So, Mg +2, nitrate NO3 -1. So now if I crisscross my charges here, I'm going to have Mg. Now since this 2 is going to be to the right of my polyatomic ion as a subscript, I need to use a parenthesis, and it's greater than 1. So NO3 parenthesis 2. So Mg parenthesis NO3 parenthesis 2. And then some examples of this. We have magnesium hydroxide. So we have Mg, which is +2, hydroxide, which is OH -1. Once again, crisscross our charges, so we see how we're going to have a subscript greater than 2 to the right of our polyatomic ion. So we need to Mg parenthesis OH parenthesis 2. Next one, potassium sulfate. So we have K plus 1, sulfate SO4 minus 2. Crisscross our charges again. Now we don't need a parenthesis here because it's not to the right of our polyatomic ion. So it'll just be K2SO4. Now we wrote some formulas. Now we're going to name them. So we know NH4 is ammonium. It's our only positive polyatomic ion that we're dealing with. And C2O4. And C2O4 is oxalate. So it's ammonium oxalate. You don't have to change the ending for polyatomic ions. Just leave them as is. And the last one, we need to look here because I see Fe. And I know Fe is a transition metal. So I might have to include that charge in Roman numerals in parentheses. So if I look at ClO3, I know it has a charge of -1 because there's a 1 here. There's nothing there. It's understood. But I have a +3 here that represents for the iron. So I'll have iron 3. Oop. We're going to erase that a little bit. So once again, hopefully this works. Should. So iron 3 chlorate. And that concludes our video on naming and writing binary ionic compounds.